One of the expectations in grade 9 is to have students explore the midpoint quadrilateral of any quadrilateral. I would recommend having them do it with paper first. So rip out a random quadrilateral from a piece of paper, find the midpoints by joining opposite or adjacent vertices, and then drawing the quadrilateral in between and making a hypothesis. You can then follow up with this GeoGebra demonstration or exploration. Start by selecting the polygon tool and drawing a random quadrilateral. I now want to find the midpoints of all four sides, so I'm going to go to my point tool and select a midpoint. And I'm going to select my four sides so that it can find the midpoint. I'm now going to join those four midpoints, so I'll go to my line tool and select segment and draw segments between adjacent midpoints. We can now have our students make a hypothesis about the shape in between there. So I can even move the vertex of the original quadrilateral to see if their hypotheses hold true. But I can also verify whether their hypotheses hold true. So if, for example, a student suggests that this quadrilateral is a parallelogram, I might measure opposite sides to see if they're equal. I might measure opposite angles to see if they're equal, or adjacent angles to see if they sum to 180 degrees. I might even find the slope of the lines. For this demonstration, I think I'm going to find the angles. So to do that, I'm going to go to my measure tool and I'm going to select angle. And if I want to measure this angle in here, I will go, and that's 143 or so degrees. And then I'm going to measure this angle in here. So I'll go here, here, and here. And we notice that those two angles are indeed equal to one another. And so we may here have a parallelogram. If we wanted to measure sides, we could do that as well. I'll go to my measure tool and select distance or length. And I can measure the lengths of those sides and the lengths of those sides. And indeed we can see that opposite sides are equal. Finally, I could also have measured slope. So I could measure this slope at point 3 and this slope at point 3. This slope here is negative 0.36, as is this one. So opposite sides are indeed parallel. And so inside there we do have a parallelogram. And regardless of how I move this, we see that it's always a parallelogram. Thank you.